Hello guys, am I audible? Am I audible everyone? Hello. Hi, 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 hi. Hello. So we will be continuing the session what we had left today, and we'll just wait for some time, probably to pick up some questions. You know, till then you just have to hit like, okay? And today is the day 3, okay? So we are. I'm just waiting for everybody to join. Okay. So how was the session till now? Day one and day two. I think my team has forgot to drop the mail. Yeah. So day one and day two were all good. Okay, perfect. So in today's session, we are going to probably discuss about distributions, different kind of distribution. Today also, I'm also actually going to write a lot of Python code so that you will be able to understand various things that we can basically work with data set and all. And whatever concepts we have discussed till now, everything will be getting covered in those practical things, right? So yes, and this will again be going till Friday. Probably everything that is required, in data science with respect to data scientist or data analyst, we'll try to cover up all the statistics part. Okay. So we'll just wait for another 2 minutes, then we'll probably start because still 7 has not been. After 7, we can probably start and we can actually do. So I'm just going to minimize my screen. So yeah. Now, guys, what all things we have discussed yesterday? Please tell me about it. What all things we have discussed? What of these things we have discussed yesterday? Yeah. What all things we have discussed? My volume is audible, guys. Please check your connections. Okay. Check your laptop and all, please. Please check your laptop and probably, but I hope my voice is actually audible because I can hear it from here. The volume is quite here. The volume, I can definitely see it. So we are going to see percentiles, everything as such, and probably discuss about it, try to see a lot of examples and, you know, let's see what all things we can basically cover as such. So important topics like distribution, all will get covered. Okay. Yes, percentiles will try to do IQR, everything with the help of coding also. So coming to the day three, okay. So here I will say that now we are moving to the advanced section of statistics. I'll still not say advanced section, but I'll say intermediate to advanced. Okay. So today, what all things we are basically going to discuss regarding the agenda. First of all, I'm going to talk about. We're going to discuss about a lot of distributions. Okay. Now, in this distribution, you will specifically have something called as normal distribution or Gaussian distribution. Then we will try to discuss about standard normal distribution, standard normal distribution. Okay, then probably one more example on Z scores. We'll try to see Z scores both with uh, Z table. There is a concept called as Z table and why Z scores are actually used. Then we will discuss about log normal distribution. Okay, then probably we will also discuss about Bernoulli distribution. Bernoulli's distribution. Then finally we'll discuss about binomial distribution, and we'll see some examples. We'll solve some examples. And then whatever practical part is left that we have not covered till now, like mean, median, mode, everything will get covered over here. So if you want to do mean, median, mode, right, we'll try to do with Python programming language. Okay, and we'll also do variance, standard deviation, standard deviation. The third thing, we'll try to create histograms. We'll try to create PDFs, probability density functions. We'll try to understand how does a distribution, this normal distribution, will look in code. We'll try to find out how to find out this IQR using code. Okay, and we'll see all these things, and some examples of log normal distribution we are going to see. Okay, log normal distributions we are going to see. Okay, so we are going to do all these things, and yeah, normal is same as Gaussian. So probably let's see in 1.5 hours if I'm able to complete this, it is well and good. But from today, the concepts that we are going to learn, okay, I can also discuss about bar plot, not to worry. Okay, bar plot, that also we'll try to discuss about it. Okay, so everybody ready? Good to go? Yes or no? Yes, I hope everybody is super fine. Shall we start? Okay, I can also discuss about violent plot. It's okay. So whatever things will come, we'll discuss about it. Okay. Okay, perfect. So let's go ahead and let's start this session. Let's take God names and start, so that God, after probably this session, we will be able to learn a lot of things. Okay. So hit like. Let's see how many likes will I be able to get today. It should be again record breaking. Okay. Record breaking should be there. And it's every time like that is my Red Bull. Okay. Okay, guys. So let's start. Now, first thing first, today we are going to discuss about distributions. Now, what exactly is distributions? Okay. Understand distribution of data. When I say I have a data set, let's say that I have a data set of ages. Okay. Like 24, 26, 27, 28, 30, 32, So we have a lot of data set. Now, when we have this particular data set, always in the first thing that we need to focus on is that how do we basically see this data set in a visualized way. Okay, because obviously this is a continuous data. We already know that this is a discrete continuous data. In this particular case, age, I'm just going to consider as discrete continuous data. Now, in the case of continuous data, what kind of graphs do you see? Probably you'll be able to understand about that specific data, right? So if I really want to get one analysis, or if I really want to start my analysis, I really need to see a lot of visualized diagrams. And that is where, when I consider this entire distribution, there are multiple ways to visualize this data through various graphs. Okay. And these graphs can really play a very important role whenever probably we are discussing about, whenever probably we are creating reports, where we are doing exploratory data analysis and many things. So let's go towards distribution. Suppose I have a specific distribution of data. I probably want to plot this data through some way. Let's consider that I want to probably plot this data through some way. Okay. And the best and the easy way that you can probably think about is your histogram, right? So we have already seen how to create histograms. You will be able to create diagrams like this, buildings like this, right? So you will be able to get buildings like this. And finally, what you do, you smoothen this histogram to get some kind of curve. Okay. And this curve right now, okay, looks like a bell curve. Okay, so considering this, let's go to the first distribution. The first distribution that I'd like to focus on is something called as Gaussian or normal distribution. Okay, Gaussian or normal distribution. Now, why, as I said, why distribution is basically used? Distribution main purpose is to why this different kind of distributions are there, so that we can basically have some idea about a data set. Okay, now first of all, when we discuss about Gaussian or normal distribution, most of the time you have seen this kind of distribution in this specific way. So here probably you have seen a bell curve. Okay, now this bell curve, this is my bell curve. Now they are very important information when I probably talk about this bell curve. This will basically, this can be your, this, just a second, this center line that you see can be your mean, it can be your median, it can be your mode. Okay, so what does this basically mean? If I have a distribution and probably this distribution follows this kind of bell curve, and one important property of this bell curve is that this side is exactly symmetrical to this side. Okay, so there are many inferential statistics that we will probably be discussing about in the future about this bell curve, about this entire distribution or Gaussian distribution. Here you can see that it is exactly similar. It is, it is exactly symmetrical. The right part of the curve, when I say consider this particular path, is equal to this part. That basically means that the amount of data that is present in this particular part will also be equal to the amount of data that will be basically present in this part. Okay, so here you can basically see that exactly this forms a bell curve, and whenever we have a specific distribution which exactly follows this kind of bell curve, we can definitely say this as a normal or Gaussian distribution. Okay, so this is basically my normal distribution. Now, why we are specifically focused on this distribution? This distribution is very much important because from this we can derive a lot of conclusions. Okay, what all different kind of conclusions we can derive, that I'll just talk about it. Now, let's go ahead and let's discuss about this distribution. Always understand, whenever, let's draw this distribution once again. Now, suppose this is my distribution. Let's consider that I'm very bad at drawing. Okay, so I think I'm good at drawing also. Okay, so this is my, I cannot draw a straight line, difficult, but it will get created. Okay, so this will be a mean median mode. Then you can go one step towards right, second step towards right, third step towards right. So what is this exactly called? Standard deviation. One step towards the right, one step or one standard deviation towards the right, two standard deviation towards the right, three standard deviation towards the right. Similarly, I may have one standard deviation to the left, second standard deviation to the left, and finally I can also have one more standard deviation to the left. This will be very much important, guys. Please focus on this. Okay, third standard deviation towards the right. Okay, now what kind of different conclusions or what kind of things we can actually conclude from this kind of graphs? Okay, as I said, this side is symmetrical to this side. Now let's go ahead and discuss about some of the important things in this. Suppose if I draw this line, can I say this is my first standard deviation towards the right and second standard deviation towards the left? Okay, so this is my region of my first standard deviation. The center one over here, I can basically write it as mu. This will basically become mu plus sigma, mu plus 2 sigma, and this will be, just a second, mu plus 3 sigma. Okay, similarly here I can write mu minus sigma, mu minus 2 sigma, mu minus 3 sigma. I hope everybody is understanding this. Yes, what did I write over here? Because of less space, okay, because of less space, I'm just trying to include it in this particular way, okay. But everybody got understood this specific things, right? How did I write mu plus sigma, mu plus 2 sigma, mu plus 3 sigma, mu minus sigma, mu minus 2 sigma, mu minus 3 sigma, right? So everybody understood this thing, right? Just give me a quick yes. Yes, okay, perfect. Now the first thing that we will probably come up with is called as empirical formula. Now this is very much important, empirical formula. Now this empirical formula basically says that you really need to understand this 68, 95, 99.7 percentage rule. Now what does this basically mean? Okay, what does this basically mean? 68, 95, 99.7 percentage rule. Okay, percentage rule. This basically indicates that, let's go with 68. Within the first standard deviation, around, suppose if I have some distribution data, let's consider that I have a data set which have 100 data points, okay, which have 100 data points. Now what does this basically indicate is that between the first standard deviation, between this region, in this entire region, around 68 percentage of the distribution is present. Okay, around 68 percentage of the entire distribution is present over here. That basically means out of this 100 data point, 68 data points will be present in this region. That is the reason it is basically called as a bell curve. That specific region, in that central area, you have a lot of data. Okay, so 68 percentage of the entire data set lies in this region within the first standard deviation. Okay, now coming to the second standard deviation. This is something very, very important. I'll also talk about what you can derive from all these things. Between the second standard deviation, around, let's come to the 68%, this is clear. Then within the second two standard deviation, right, within the two standard deviation region, which is this specific region, around 95 percentage of the entire data lies in this region. Okay, 95 percentage of the entire data lies in this region. And similarly, if I go and consider with respect to the third standard deviation, which is from here to here, around 99.7 percentage of the entire distribution will fall in this region. Okay, so that is the reason why it is basically called as 68, 95 and 99.7 percentile loop. Okay, so everybody is clear. That basically means now if you have a distribution which is Gaussian or normally distributed, then this conclusion can definitely made that within the first standard deviation how much data is basically falling, within the second standard deviation how much data is falling, and within the third standard deviation how much data is basically falling. Everybody clear with this? First standard deviation basically means this is the region. First standard, one standard deviation to the right, second, one standard deviation to the left. That combined together is one standard deviation. Okay, first, second and third standard deviation. Please understand in this. Now let's see some examples. Some of the examples, if I talk about, like height, I'll also show you examples with respect to coding. Okay, so height, if I say height, height is basically normally distributed. Who is saying this? I am not saying it. The domain expert is basically saying it. Now, who is the domain expert in this particular case? In this particular case, the domain expert is a doctor. Doctor have taken various samples from different places, and whenever the doctor was constructing this bell curve, it was forming something like this. Okay, like this kind of bell curve. And from that, he was able to understand, he was able to derive, right? He or she was able to derive that within the first standard deviation, how much data is basically falling, within the second standard deviation, how much data is falling, and within the third standard deviation, how much data is falling. Everybody clear with this? Let's take another example. So this was my first example. Second example, if you consider weight, weight will also follow a Gaussian distribution. Third, I hope everybody knows about iris dataset. In iris dataset, if you talk about petal length, sepal length, it actually follows Gaussian distribution. Okay, I will show you practically. Don't worry about that. Does that following the empirical rule necessarily imply that it is distributed? See, whenever you have a Gaussian distributed data, at that time it will follow this 68, 95, 99.7 percentile rule. Okay, so this was the thing with respect to Gaussian or normally distributed. Okay, that basically means, suppose now let's consider one thing. Everybody's clear with this at least. Shall I start the next topic? Because from this we'll try to derive something which is called as Z score. Okay, everybody is clear with this? Yes, hit the like button. I need to see a lot of likes now, because now I'm going to use multiple colors and show you it in an efficient way. Okay, but everybody is clear with this? I'll talk about iris dataset. If you have not seen iris dataset, what it is, I'll show you practically. Okay, I'll talk about it practically. Okay, don't worry. This rules apply to those data set which follow a Gaussian distribution or normal distribution, like this kind of curve. Now, percentage, not percentile. Okay, Souvik, percentage of the entire distribution. Okay. Okay. Now let's go ahead and try to see this. Let's take an example. Okay. Suppose I have a data set where my mean is 4 and my standard deviation is 1. If I have this two information, can I construct a distribution? Suppose this is 4. Then in the next step, what it will come? 5, 6, 7, 8, right? And then 3, 2, 1 and 0. So I will be able to create this. And let's consider that this is basically following this kind of distribution. Okay, so this basically follows this kind of distribution. How a data is basically distributed, normally distributed and all, we'll discuss all about it. Don't worry. Okay, everything. Rome is not built in one day, guys. Okay, it will take time. Okay, so we have kept this 7 day session where you understand each and everything. If you want to learn the advanced thing, just tell me, half an hour I'll complete all the advanced thing. Then everybody will forget what needs to be taught, So when we go from basics, you will be able to understand each and everything. Is it clear, or do you want to directly learn the last thing? Tell me. Should I directly show you the last day, 7 day that I'm actually planning to do, or do you want to learn in this particular way? Tell me. Okay, you can tell me. Okay, and based on that, I will may directly teach you the last day things, and then you can go home and probably be confused whenever there is an interview going on, right? Okay, now understand this middle one is basically your mean and standard deviation. Sorry, mean is 4 and standard deviation is 1. Okay, now see one thing, guys. If I talk about 4.5, now tell me, my question is that where does 4.5 fall in terms of standard deviation? In terms of standard deviation, where does 4.5 basically fall? Tell me. Where does 4.5 fall in terms of standard deviation? Okay, just tell me. So you may be thinking, okay, 4.5, where exactly it is? It is somewhere here. Obviously, when I say 5 is first standard deviation to the right, that basically means 4 will be plus 0.5 standard deviation to the right. Yes, everybody is agreeing with this? 0.5 standard deviation, right? Understand, 0.5 standard deviation. If you say 1 standard deviation, it is basically coming to 5, right? It is 0.5 standard deviation, right? Okay. Now, similarly, if I say, where does 4.75 fall? Then how you will be able to see it? See, the standard deviation was 1, right? I told 4.5. So 4.5 will be something falling over here, and this is like 0.5 standard deviation. But in the case of 4.75, it will be very much difficult for you to do the calculation, right? So that is the reason what we can do is that we can use a concept which is called as Z score. Now, Z score will basically help you find out whenever I talk about a value, how much standard deviation away it is from the mean. Okay. So this formula is x of I minus mu divided by standard deviation. Okay. X of I minus mu divided by standard deviation. Now I need to find out for 4.75. Okay. So let's go and compute. So over here, I will just write, okay, I will just write 4.75 minus mu is what? Mu is 4. 4 divided by standard deviation is 1. So here I am actually getting 0.75. So now I can see that it is 0.75 standard deviation to the right. Why it is saying right? Why it is basically said as right? Why not left? Why not left? Why not left? Why I am saying that it is falling here 0.75 standard deviation to the right? Because this is positive value. This is positive value. Okay. Now, if I give you the same question, try to find out where does 3.75 fall? Like how many standard deviation, whether what should be the standard deviation with respect to 3.75? Then you go and apply the same formula. So here I'll say Z score is equal to 3.75 minus 4 divided by 1, which is nothing but minus 0.25. So whenever minus comes, that basically means you have to check in this side. And it is basically saying that 3.75 will be falling somewhere here. That is nothing but minus 2.25 standard deviation to the left. Right? I hope everybody is able to understand this. I hope everybody is able to understand this. Yes or no? Yes or no? If yes, definitely hit like, and I'll be teaching more. Many things will be actually coming, and I hope you are loving the session. I hope you are able to understand with respect to the complexity. See, understand, now you are learning something which will be heavily used somewhere. Why we are doing this? Everything will come now. Okay, why not? Everything will come. Everything will make sense to you. Okay, so till here, I hope everybody is able to understand. Okay. Now, let's go to the next thing. Suppose I consider this same graph. Now you understood, if I really want to find out how many standard deviation to the right or the left I need to find out, I can definitely use Z score. Okay. Now, let's consider this thing. I will use the same graph. I'm using the same bell curve. Okay. Only my diagram is becoming bad. Okay. So this is my bell curve. This is my 4. Okay. This is my 5, this is my 6, this is my 3, this is my 2, this is my 1. Here you know that my mean is 4 and standard deviation is 1. Okay. Now, understand one thing over here. I'll talk about Z score again. Don't worry. Now, let's apply Z score to every values. What will happen? If I apply Z score to every values, what will happen? Okay, what is Z score formula? X of I minus mu divided by standard deviation. Okay, you know the mean is nothing but 4, standard deviation is 1. Now, if I apply Z score to everything, initially my distribution was like this: 1, 2, 3, 4, 5, 6, 7. Okay, now this was my distribution initially. Now, after applying Z score to this, what will be my distribution? That will be coming. Apply for 1 first of all. So, if I apply Z score to 1, then what will happen? 1 minus 4 divided by 1. This is minus 3. Can I say this 1 is getting converted to minus 3? Yes, 1 is converted to minus 3. Okay. Then if I apply this Z to the next element 2, then what is 2 minus 4 by 1? It is nothing but minus 2. So here I am actually getting minus 2, right? Then if I go and apply the Z score to 3, then what will happen? Z of 3, 1 minus 4, sorry, 3 minus 4 divided by 1. Okay, sorry. So 3 minus 4 divided by 1, what will happen? Minus 1. So minus 3 will now get converted to minus 1. then 4 will get converted to 0, then it will get converted to 1, 2, 3. Okay. Now understand the main magic in this. With the help of z-score, is this not the standard deviation of the same elements that we got over here? Yes or no, guys? Is this not the standard deviation of these all elements that we got after applying the z-score? After we applied this, initially my data set was like this, then I got this. This element falls at -3 standard deviation. This elements fall at -2 standard deviation, right? So here you can definitely see that I'm able to get the standard deviation, right? Yes. Now what is happening? See over here, one beautiful thing that is basically happening. I had a distribution which was 1, 2, 3, 4, 5, 6, 7. After I applied a z-score, this got converted to 0, 1, sorry, -3, -2, -1, 0, 1, 2, 3. And probably, yeah, right? I got this, right? Now, what is this distribution then called? Anybody guesses? Any guesses? What this was initially a normal distribution or a Gaussian distribution. After I applied a z-score, what kind of distribution we are actually getting? And what is this basic distribution called as? Anyone? Anyone can answer me. So this distribution, where some people have already told it, is called as standard normal distribution. Standard normal distribution. So one of the most important property with respect to standard normal distribution is that your mean is 0 and standard deviation is 1. Is this satisfying this property or not? It is being satisfied, right? Satisfying this property. Yes. So can I write a random variable x or y will belong to standard normal distribution, where specifically your mean will be 0 and standard deviation will be 1. Right? So I hope you are able to understand this, guys, now. Okay. So I need to see, if you are able to understand, I need to see Krish OP. Okay. OPs should be there, right? So first time I probably think you are able to understand in this way, right? So after applying a z-score, we are able to get into a different distribution, which is called a standard normal distribution. Now the question rises, why do we do this? Why do we do this? What is the use of doing this? Okay, what is the use of doing this? Let's go ahead with one practical application. One practical application. And we do this in machine learning. We do this in most of the algorithms. Okay, we do this with most of the algorithms. Okay, now let's go ahead and try to see the practical application. Suppose I have a data set. Let's consider that I am solving a machine learning problem statement. I have a data set which is called as, okay, just a second. Okay, perfect. So I have a data set. In this particular data set, let's say that I have features like age. Okay, I have features like salary. I have features like weight. Suppose in this particular data set, I have these 3 columns. Okay, I have this particular things. Okay, now understand one thing. Age, by what unit we will calculate? By years. Salary we may calculate by rupees or dollar. Weight we may calculate in kgs. Understand these units. These are what? These are basically units of calculation. Okay, units of calculation. Now whenever I have some values like this, like 24, 25, 26, 27, salary may be 40k, 50k, 60k, 70k, something, right? Weight may be 70 kgs, 80 kgs, 55 kgs, 45 kgs, right? Now here, when you have this kind of data, always understand, okay? Now in this data, obviously you can see the units are completely different. Our main target should be that we should try to bring up in a form, probably in this particular form where my mean is 0 and standard deviation equal to 1. Okay? At that point of time, I can definitely apply standard normal distribution. That basically means I can take up this entire data and apply z score and convert this into standard normal distribution. Okay, I can convert this into standard normal distribution. Similarly, I can go ahead and take up this particular data set. I can apply z score and I can basically convert this into standard normal distribution. This process is basically called as standardization. Okay, very super important. Many people will talk about normalization. Okay, normalization. I'll talk about the difference between standardization and normalization. Whenever we talk about standardization, in short, internally there is a z score formula getting applied. Okay, so I hope you are able to understand, right? Everyone, I guess everybody is able to understand with respect to standardization. Guys, those whoever are spamming, they will be removed from this entire live thing. I'll hide the user completely. Example Naveen. Okay, so Naveen will be moved out now. Yes, he is moved out now. Now you cannot see Naveen message. Okay, focus on learning over here. Okay, so standardization is a process where I am basically trying to convert a distribution into standard normal distribution. The property is that the mean is 0 and the standard deviation is 1. Now let's go ahead towards something called as normalization. Now what exactly is normalization? In standardization, whenever we talk about, here we are getting converted as mean is equal to 0 and standard deviation equal to 1. Okay, mean equal to 0 and standard equal to 1, standard deviation equal to 1. Now in normalization, you have an option. You will say that I want to shift this entire values or whatever values that I have between 0 to 1. Let's consider it like this. I want to change all these particular values between 0 to 1, right? So in this particular case, I may definitely apply normalization. Okay. Now, how do we do normalization? There is a very important formula which is called as min-max scalar. In the min-max scalar, you just have to provide 0 to 1 and automatically this kind of normalization will happen. And yes, I will show you practically also, don't worry. If I want to probably shift this between -1 to +1, I can basically apply this. Okay. So normalization gives you a process where you can basically define the lower bound and upper bound and you can convert your data between them. Okay. Now, very important thing, where do we use normalization? I hope everybody knows about deep learning. In CNN, whenever you are doing image training, image classification or object detection, in this particular case, understand every images has a pixels. Suppose I have a 4x4 image. 1, 2, 3, 4. 1, 2, 3, 4. Each and every pixel ranges between 0 to 255. Okay. Each and every pixels is basically between 0 to 255. Okay. Now 0 to 255, what we do before we start training, this can be applied with min-max scalar and it gets converted between 0 to 1, where the minimum value 0 is assigned to 0 and the maximum value 255 is converted to 1. Okay. So when we do this, automatically we can apply this kind of min-max scalar or normalization in this specific order. Okay. So in this particular case, I will definitely not use min-max scalar because min-max scalar has a different formula. I will take each and every pixel, divide by 255. divide by 255. That's it. So when we do this specific division by divide by 255, all your values will be getting changed between 0 to 1. And this is another type of normalization process. Okay. So I hope everybody is able to understand this. Okay. So till here we have discussed about min-max scalar, we have discussed about normalization, standardization. Now let's solve one practical example for Z score. Practical example. Okay. Recently, what match has happened? Cricket match, if everybody knows what I am talking about. What cricket match had happened? Tell me. Let's discuss about this. Okay. Okay. So what type of match had actually happened recently? Cricket match. I hope everybody is the fan of, let's say that. Okay, recently India versus South Africa, where India lost it, obviously. Okay. Now let's consider that if I consider ODI series, let's say ODI series, right? And every time in last year also ODI series happened, this year also it happened, right? Let's say that I'll write down the question. Everybody open your book and all. This will be very, very interesting. The series average of 2021 was somewhere around, let's say, 250. Okay. The standard deviation of the score, was somewhere around 10. And Rishabh Pant final score, final score Rishabh Pant final score, let's consider that he has actually uh, played well. I know final score was 0. Okay. Let's say that I'm just taking for an example. Okay. Let's say Rishabh Pant final score was 70. Okay. So this was the series information for 2021. Let's consider. Okay. Cricket. Yes, this is for cricket. Cricket. Bat and ball. Lagan. Okay. Boyne Francis says so boring. So I'm going to remove him. Okay. Because he does not deserve to be in this channel. Okay. So he's also removed. Okay. Let's consider that Rishabh Pant basically in the final score, he has basically scored 70. Let's consider for an example. Now, similarly, I have a data for 2020 series. Okay. Let's say the series average in 2020, let's say that the series average is a little bit different. In 2020, the series average of the team scoring in 2020 was 260. The standard deviation of the score of all the matches is 12. Okay. And then over here, probably Rish Pant I have written. Okay. Final score is 75. Not 75. Let's say his final score is 68. Now, my question is very much simple. Okay, my question is that this two data I have compared to both the series, in which year Rishabh Pant final score was better. So this is the question. So just by seeing this specific data, what do you think, guys? Which score is better? Which score is better? Which score is better? Whether Rishabh Pant played well in 2021 or whether he played well in 2020. So for checking this, obviously many people will say 2020, 2021, lot of confusion will be there. So we will just try to apply for Z score. Now for the 2021, we will apply the Z score. So Z score will be nothing but, it will be x of I minus mu divided by standard deviation. We know what is x of I in this particular case. X of I is nothing but um x of I is nothing but Rishabh final score is 70. So 70 minus 250 divided by 10. So what we are getting over here? What we are getting over here? And similarly for 2020, my Z score will be x of I minus mu divided by standard deviation, which is nothing but over here 68 minus 250, sorry, minus 260 divided by 12. Okay. So first one, let's go and compute with the calculator. Let's go and compute with the calculator. So 70 minus 250 divided by 10. So this is, okay, let me do one thing, guys. You know, this properly, this values may not be coming. Let me change this data a little bit, okay? Let me change this data a little bit, okay? Rishabh Pant final, I'll say average score, not final score, so that we change this data a little bit. Otherwise, the data will be very, very bad, okay? Rishabh Pant average score, let's consider that it is 240, okay? And Rishabh Pant average score is somewhere around 245, okay? Let's consider like this, okay? 240 and 245. Because I gave one score, so that is the reason a huge standard deviation is basically coming, okay? At that point of time, I'm just taking average score, okay? Average score of the series, guys, okay? Average score of the series. Rishabh Pant, this player's average score of the series, okay? Average score of the series. Here also I'm writing average scores of the series, okay? Average score of the series, okay? Now let me just make some changes and let me put somewhere over here as 240. So 240 minus average score of the series, guys. Three match series. Arumai Shaha. Okay. So 240 minus 250 is nothing but minus 10 divided by 10. So this is minus 1 standard deviation. And this data will now change to 245. So 245, this will be minus 15 divided by 12, which is nothing but 15 by 12, which is nothing but minus 1.25. Okay, clear everybody? Okay, आकाश सिंह if तीनों मैच में 80 मार दिया तो हो गया ना 240 एवरेज. So understand, along with the not out rule, something 240 is the average. Okay, let's consider in that specific way. I know the data is not approximately right, but I could also, instead of Rishabh Pant average score, I could have team average score. Okay, team average score, and probably team played well, probably in the last match or the first match, like that. Okay, in which series they played well. That also you can basically say. Over here, instead of Rishabh Pant, I could write team average score. Team score in final match. I messed up with the problem statement because I was just thinking something. Score final match score, like that. Okay, team final score. Here also I can say team final score. This will probably be more problematic. Team final score. Now, based on this, I have always, again, this is an example, guys. Just think of it. The main idea is to teach you something so that you can apply that anywhere. Okay. So here I have got -1. Okay. Here I got -1. Here I got -1.25. Now see, I have seen that the mean is 2 in 2021. So let me write it down again for you. So if in 2021, okay, the mean is 250. Over here you can see the mean is 250. X of I is nothing but how much? It is nothing but 240, and the mean is 10. Sorry, and the standard deviation is 10. Okay, and the standard deviation is 10. If I have this information, can I draw the bell curve? Can I draw the bell curve? So this is my bell curve. The mean is how much? 250. Standard deviation is 10, basically means this will come as 260, 270, 280, right? This will come as 240, 230, 220, right? And this is my mean, right? Now, where does 240 fall into? 240 is falling into -1 standard deviation. So that basically means 240 will fall here, right? Now, in 2020, you know that your mean is how much? 260, right? Your mean is 260. X of I, that is your final score, is 245, and your standard deviation is nothing but 12. Okay. Now, based on this, I will definitely be able to create another curve which will have this kind of bell curve, and my central element will be 260. Since my standard deviation is 12, this will become 272, then it will become 284, then it will become 296. Similarly, over here it will become 248, then it will become 236, then it will become 224, right? So here I have my value over here, and what is the standard deviation over here? It is 1.25. So 1.2 minus 1.25 is this specific standard deviation, right? Now here you can see the area is little bit less, right? Here the area is little bit more. So where do you think India has probably performed well in the final match? In the final match, whether India performed well in 2020 or in 2021? Based on this information basically tells many things about probably the pitch condition. Whenever we say the standard deviation is less, that basically means most of the score was rotating around that much values, right? Right? So tell me where probably India may have performed well. Where probably India may have performed well, in 2020 or in 2021? Yes, yes, many people are saying 2021. Many people are saying 2020 again. Why? 2020 or 2021? Understand, guys, here the standard deviation is more. Here the standard deviation is less. Understand, over here, obviously the Z score value is -1. Here the Z score value is -1.25, which is greater. Which is greater. Okay. So think over it. This will be an assignment for you. Tomorrow I'll ask you which one was better. Okay. Just tell me the answer tomorrow. Okay. Based on the Z score, because I try to convert those values with respect to standard deviation. Okay. So just tell me the answer tomorrow. This will be an assignment for you. But I hope you understood this. I hope everybody understood this. Yes. Think over it. Which score is better? Okay. Which score is better? Okay. Okay. Now let's go to one more practical example of Z score. Okay. Now this example most of the time with respect to statistics will come. This may be probably asked in interviews also, and this is a very important question. Okay, let's say that uh, I will probably take one very good example and show it to you how to be done, how you can basically do this, and how you can actually learn it. Okay, so one problem statement that I am actually going to give to you is that uh, this problem statement will be quite interesting, guys. Okay, so try to do this. One example I'll give you, then we will try to see. Let's consider that I have an x random variable. I have an x random variable. So let's come to the stats interview question. Stats interview question. Okay. Now in this stats interview question, let's say that I have a random variable x, and let's say that this random variable has this kind of distribution: 4, 5, 6, 7, 3, 2, 1, and let's say that I have a bell curve which looks like this. Okay. Now I want to know, my question is very simple. My question is, what percentage of scores fall above 4.25? Did you understand the question, everybody? Yeah, if I answer everything, then what research you will do more? Okay. What research you will do more, right? Z score basically gives how much standard deviation away from the mean, right? Okay. So have you understood the question or not? No? Right? No? Yes? No? No? Yes? Okay. Many people are saying yes, no, yes, no. Okay. Now let me talk about it. Okay. Now understand one thing. Where does 4.25 fall? 4.25 will fall over here. So this is basically my mean, and 4.25 will fall over here. Let's consider that it is falling over here. Okay. My question is that these are my scores, right? Let's say that these are my scores. 2, 3, 4, 5, 1, like these are my scores. I need to understand from this distribution, from this my entire data set, what is the percentage of scores that falls above 4.25. That basically means I am interested in this region. I am basically interested in this region. I am saying that what is the percentage of the scores that are greater than 4.25? This is my question. Okay, simple question is this. And now we'll try to understand how we can use z-score in this. Okay, so everybody knows about z-score formula: x of I minus mu divided by standard deviation. Here my mu is 4, standard deviation is 1. What is my x of I? X of I is nothing but 4.25 minus 4 divided by 1. This value is 0.25 standard deviation. Okay, 0.25 standard deviation. What does this basically mean? 4.25 falls 0.25 standard deviation from the mean. Okay, from the mean. From the mean, it is basically fall into 0.25 standard deviation. Now, I got the standard deviation. This is I got with the help of z-score. But now, what is the next very important thing? Obviously, from this, we will not be able to understand, okay, how much, what will be the percentage then? Probably this I have got that it is 0.25 is my standard deviation or a z-score. My z-score is 0.25. Now, I'm interested in this region. Okay, I mean basically interested in this region. So how do I come up with the overall percentage from this particular region? Okay, now understand one thing. This is a symmetrical bell curve. That basically means the entire area I can basically consider it as 1. Okay, I can definitely consider it as 1. Now since I am interested in this region, I will say this region as tail. Okay, whenever we talk about tail, the region that I'm actually interested in, basically I want the value with respect to this. One part of the region, I'll say it as tail. The other part, that is the remaining portion, I will basically say this as body. Full from here to here. So this will basically be my body. Okay. Now understand one very important thing. How do I check based on this Z score what should be the value or what should be the body curve, the area of the body curve? I want to find out what is the area of this. Z scores actually help you to find area of the body curve. Area of the body curve. How do we find out? I'll talk about it. Okay. Z score will definitely help you to find out the area of the body curve. Now, guys, just think over it. Okay. What do you think this percentage may be? This red region percentage may be. What do you think? Over here, three numbers are there. Let's say that total numbers are 7. And when I say three numbers on the right hand side, what may be the percentage? What may be the percentage? Just think over it. Just basically with common sense. What may be the just basic common sense, guys? If I said 3 by 7, what is 3 by 7? It is approximately around 48 to 49%, right? Now, can we calculate the same thing with the help of Z score? The answer is yes. I have already seen the Z value is 0.25. Now let me do one thing. Let me open something called as Z table because I want to find out the area of the curve, right? So Z table, if I go and search for it, you will be able to see in the first link. Okay. You will be able to see in the first link. And over here, I'll just go over here. Now see, this is how my curves look like, right? See over here, Z score, I'll just use another table because this table does not look right. Okay. So let's consider this table. Okay. So always remember three types of Z score we can basically get. One is this type, which again I'll be discussing. One is in this type. Okay. Now see this. Left Z table and this is right Z table. Okay. Just a second. I will just show you how to make the readings over here. 2.2 point Z is 0.25, right? 0.25. Do you see, guys, over here? Okay. See over here. What is my Z score from here? What is my Z score over here? 0.25. And remember, this Z table will be giving me the area of the body curve. See, a Z table shows the area to the right hand side of the curve. Use these values to find the area between Z is equal to 0 and any positive value. For area in the left table, look at the left tail Z table instead. Okay. If you want to find out the area in the left tail, search for it, guys. If you want to find an area in the left tail, look at the left tail Z table instead. In this particular case, let me take left Z table. Okay. Because I want to look at the area of this. See this, guys. This is the area. Right now, this area I want to get the answer, right? If I get the answer of this area, I can just subtract 1 minus the left body curves. 1 minus the left area, right? I want to get this particular area. Everybody is able to understand or should I repeat it? Tell me. Just tell me, guys, whether I should explain once again. Let me explain once again. Okay, everybody is able to see this. Okay. Over here, just see very, very important thing. The Z table shows the area to the right hand side of the curve. Okay. Use these values to find the area between 0 and any positive value. For area in the left tail, look at the left tail Z table instead. Okay. So here you can see that I want to see the left tail or right tail. Okay. What you want to see? Okay. First of all, see that. You come to this particular diagram. You want to see this part or this part? Obviously, you want to calculate this part, right? But understand one thing. In order to calculate this part, if I get the value of this part, I can just subtract 1 minus left area, right? If I subtract 1 minus left area, will I not be able to get the right part? Right? Otherwise, you directdirectly go and see in the right table. Okay. Again, I'm showing you. Here you can see 0.25, 0.25, right? So 0.25, you will be able to see this much. This area will be giving from mean to this standard deviation. Right table is given. Don't worry, left table is also given. See over here, left table is also given. Yeah, left table is also given. You can also check this. This table will be giving you the value between this to this. Then probably you have to find out this one or subtract 1 minus this area. Then you will be able to understand it. Okay. Now I will go to the left table. Understand. Again, I'm going to repeat, guys. Here clearly it is given that for area in left table, left tail, look at the left tail Z table. Why I am seeing left tail? Because if I go over here, this is my right tail. This is my remaining body. Left tail can become this part. So from the entire body, if I subtract 1 minus this, I will be able to get this. Very much simple. Now, how do I check this? I'll go over here. It has given me the instruction over here. For area in left tail, look at left tail Z table instead. So if I go and see, this is my left Z table. Okay. Now I will go and find out the Z value of 0.2 and 0.2 and 5. So how much I am getting? 0.5987. Okay. So 0.5987 will be my value of this. My area of the body curve will be 0.5987. Now, in order to find out this, I will subtract 1 minus 0.5987. Now, what is 1 minus 0.5987? 1 minus 0.5987. This is nothing but 0.4013. Right? So, what is the percentage of scores that fall above 4.25? It is nothing but 40%. Okay. So I hope everybody is able to understand. Yeah, Data Scientist Pro, come with your real name. I'll show you some examples of okay overloaded. Vaibhav Singh says, why subtracting from 1? It's very simple. No, see guys, again I'm talking about this. My question is that this is my mean. From this particular curve, I want to find out what is the percentage of the distribution. Then what I can do if I want to find out this curve? I can take this whole curve, subtract with the left one. Then I will be getting this one. Right? So that is very much simple. Right? So here you are able to get 40%. Now did you understand how important it is basically to understand Z-score? Yes, 0.59 is the mean to all the left. This entire region from this to this, from 0.25 standard deviation to the left part. Right? Yes. So now did you find out how important this is for the interview questions, guys? If you are able to explain, why not directly taking from the right table? Understand, guys, right table is not given. No, this is not right table. This is only given from here to here. Only here to here. Yeah, here to here only this is given. If you want to find out from left table, then this is the diagram for this, for left z table. Okay, understand one thing, very much important. Okay, Nilasha Sen, you cannot take it from right table. Right table, there is no information about it. You can see this graph, right? It is only giving information from here to here. In the left table, you will be able to get the information of the body of the area of the body of this particular part. Okay. Now Akash Singh says, give one practical example. I've given you one practical example, right? अब इससे ज्यादा और क्या प्रैक्टिकल दूं मैं आपको? Okay, perfect. So this was an example with respect to Z score, standardization, all these things we have probably discussed. You want to do one more example? You want to do one more example? Just let me know. You want to do one more example, guys? You want to do one more example? No, you do it. Okay. So the question is, in India, okay, let's do one more example. In India, the average IQ is 100 with a standard deviation of 15. What percentage of the population would you expect to have an IQ lower than 85? Okay, guys, do this example quickly. Okay, do this example. Okay, let's see this. So my Z score will be what? So first of all, let's discuss about this graph. So here you can see that this is my graph. Okay. So this particular value is how much? The mean is 100. My standard deviation is 50. So 115, 130, 145. Similarly, I have 85, 70, 55. Okay. So I have all these values over here. Now with respect to this, first of all, let's go and compute the Z score. How do you compute the Z score? The same example that what we have done over here. Here in this particular case, 4.25 falls over. We are just taking IQ lower than 85. Okay. So what is IQ lower than 85? So it will become 85 minus 100 divided by 15. What it is? Minus 15 by 15. It is minus 1. So 1 standard deviation. This is my mean. This is my minus 1 standard deviation. Now this is the area that I want to find out. Now when I want to find out this particular area, this area is already the body part, the left of the curve, right? So what I will do, I will just go and compute for minus 1. Now if I want for minus 1, what it is? Go and compute it over here. How much it is? 1.0. So this is 0.86. Let me just compare the answers. Do it, guys. $15.87. Probably you're doing some mistakes. See, the thing is that you're not right now watching the exact Z table correctly. Or let me just select some different Z table so that you will get an idea. I'm actually not able to find the right Z table. Yeah, this looks good. Yeah. So I will give you the link. Point 0.84. So what I'm actually getting? 0.84134, right? Is everybody able to see this? Is everybody able to see this? 0.84134, right? This is plus 1. Understand, this is plus 1, right? Plus 1 when I say, understand over here, plus 1 when I say, it is basically from this region to this region. Okay. Now if I subtract 1 minus 0.8414, 0.84134, that will basically be my values, right? Clear, everybody? Lower than 85. Understand, lower than 85, lower. Okay. You may also get a question IQ between 90 to 120. Like this question also you may get for the same problem statement, right? So you may get questions like this. At that point of time, again, you have to solve it in a different way. But here is just an idea to talk about what is body area of the body. Okay. Everybody clear? I know if you're not able to understand it, please revise, guys, because we have limited time. I still need to cover many topics. I thought of doing some programming also with you. Yeah, negative will not matter. If you say negative, it will come from here. If you say, sorry, if you say negative, it will come from here. If you say positive, it will come from here. Understand, both the side are symmetric. Minus 1 also you can look. That only I'm saying, no, in the table, whatever you are able to find out, you can definitely check out from minus 1 also from top. Minus 1.0. Same thing you'll be getting, right? Minus 1.0 is 1.15886, which is 1 minus 0.84, right? Same thing. Okay. Now let me do one thing, guys. Quickly show you Google Colab Pro so that we can have some programming sessions. Quickly, let's complete some simple things. I know if you are getting tired, just imagine how much tired I may be getting. So let's not break the flow and probably learn a lot. Okay. Okay. Now quickly start answering me how to do with Python. Okay. So first of all, I'm going to import some libraries as this. Import numpy as np. Import connect it. Import matplotlib pyplot as plt. Okay. And then probably I will say matplotlib inline. So all these things we are actually done. Z test आएगा भाई आएगा. No guys, I have seen the right Z table. This is only the Z table score, right? See, for 1.0 I got how much? For 1.0 I got 0.84134. If I subtract 1 minus 0.84134, I'll be getting the same thing over here, 0.15866. Okay. So here it is, and then probably I'll also import statistics. Okay. Now first thing first, how to compute mean, median, mode. Okay, we are going to see that. First of all, let me load a data set which is called as, I'll load a data set which is called as tips. Okay, and this will basically be giving me df is equal to this one. Okay, then I'll say df dot head. Okay, so here you can see this is my entire data set. Now quickly, if you want to see how to do mean for this, let's say that I'm using np.mean function for finding the total bill mean. Total bill of mean. Okay, so if I execute this, you will be able to see the answer. So this is the what is the mean of the total bill. Okay, if I want to probably find out the median also, you will be able to find out median, np.median, df of total bill, right? So here you will be able to see np.median. Okay, so over here you see some differences. If you are seeing some differences, think that there may be something like, you know, some kind of outliers also. Okay, if you want to try for mode, I can use statistics.mode, and again I will be using df of total underscore bill. So here you go. This is got mode is nothing but 13.42. Okay, now the thing is that if I want to go and see my box plot, which is basically used to see outliers, so if I use df of total bill, total underscore bill, so here you will be able to see my box plot also. So this is one example of box plot. So does this indicate it has an outlier? Yeah. Okay. Now definitely over here outliers is present, but what is this? This is 25%, sorry, minimum, 25 percentile, median, 75 percentile, and max. Okay, so all these things we have calculated. If you write df of sns dot, there is something called as hist plot, which will basically help you to create histograms on a specific feature. So if I execute this, you will be able to see one example which looks like this. Is this a normal distributed data? Is this a normal distributed data? I guess no. If you want to see with probability density function, I'll be using KDE is equal to true. So with KDE is equal to true, does this look like a normally distributed? No. It is like a little bit skewed towards the right. I'll also show you some examples with respect to normally distributed data. So for that, I will do sns.load underscore dataset. I will be using iris dataset. Iris flower dataset basically is the dataset which will actually help you to give a data of a different types of flowers with respect to iris. So here you will be able to see that df1.head. Okay, so here you have flowers like setosa, versicolor, and here you have four features: sepal length, sepal width, petal length, and petal width. Now let's see, I will just try to plot the same thing with one of the feature. Okay, let's say that I am doing it with sepal length, sepal underscore length. Is the spelling wrong? Oh, df1. So here you can see that. Does this follow a Gaussian distribution? Does this follow a Gaussian distribution? No, I guess. Let's try with sepal width. Finally, we'll be able to see something. Wow, this follows a Gaussian distribution. Everyone, guys, you have to do it in Google Colab, not Colab Pro. Okay, you do it in Google Colab because Colab Pro takes a subscription charges for $10 per month. Definitely, we can definitely say for this, this is a Gaussian distribution. Yes. So this is specifically a Gaussian distribution over here. Okay. And here you can also apply that rule, that is 68, 95, 99.7 percentage rule. So all these things you can basically check out over here and you are getting this. I'll also show you how to construct this PDF function and all as we go ahead. Okay, it is normally distributed. Definitely we can say that it is normally distributed. Okay. So this was one example with respect to normally distributed. This is not normally distributed, you know. SNS dot count plot of df of, if I use count plot with respect to species. Species spelling is wrong. Okay, df1. Again, I'm writing df. What is this plot, guys? What is this plot? यार तुम लोग मेरा 1000 लाइक्स नहीं करोगे मैं तब तक ले क्लास नहीं बंद करूंगा. चलो. What is this plot? This is our bar graph, right? This is our bar graph, right? This is our bar graph. Bar plot or bar graph, whatever you want. Okay. एक लास्ट चीज कर ले. एक लास्ट चीज कर ले. How to find out IQR? Then I'll stop. Okay. One last thing. Should we do outliers? How to do outliers in through code? Okay, percentiles. Let's do for percentile. So for percentile, I can use np dot percentile, and I can use my df of. Let me do one thing. Let me open one example that I had written for you, and probably will complete this and we'll do it. If we do this much, I think it will be sufficient for today. Okay. Let me just show it to you. कल करें. I will finish it off today. No, tomorrow there will be a new topic that will come. If you want to complete quickly, just hit like, make it 1000 subscribers. Otherwise, I'll not stop the class. How is this? Eh? हम भी अपने एरिया के गुंडे हैं. Hmm? हम भी अपने एरिया के गुंडे हैं, like that they'll say. No. Okay. So I will basically use over here like this. Let's say I'm going to use sepal length, and here I can basically give some parameters. Like let's say that I want to get the 25 percentile and 75 percentile. Okay. So if I execute it here, sepal length, here's a df1. What is this hell? Okay, why I'm making this mistake? So here you can see that I'm getting 5.1 as the 25 percentile, and 75 percentile is 6.4. So my IQR will be 6.4 minus 5.1. Okay. If you want to probably get the 99 percentile also, you can basically write like this, 99. So here you will be able to get the value 5.1 and 7.7. Right? Okay, so I can understand people problem. Let's do the outlier formulation through code tomorrow. Okay. All these course materials will be added in the community session. Please try to join the community session below. Or why, guys? How many of you have taken one neuron? Please go ahead and take it, guys. Right now it is for lifetime. You can raise any course request. You can do anything. You can kill us for that. You can throw bomb at us. Whatever you want, you do. Okay, but please make sure that you take one neuron. There you are probably able to get 100 plus courses for lifetime. Okay, and probably in just a month you will be able to see more 20, 30 courses getting added every day, every month. Okay, so please go ahead, take up. There is also a discount coupon on my name, Krish10. यूज इट यार, इतना मेहनत करने के बाद तो कुछ तो दो. 1 घंटे का सेशन तो ऐसे ही ले लेते हैं हम. हम्म. So please do that. I have also taught stats in iNeuron. Binomial Bernoulli, it took time, no? Finishing off. Tomorrow we'll discuss that, okay? DS roadmap has already been put up, guys, in the One Neuron platform. So please go ahead, take it. यार अच्छा चीज दे रहे हैं यार. For 7,000 plus 7,080 rupees, उसमें भी 10% discount. You are getting courses for lifetime. So tell your friends, guys. Do it. What is the coupon? Coupon is Krish10. Check out the description of this particular video. Every information is given. Okay. You can raise any demand. I'll give you some funny demands that was raised. Sir, upload German language. I need to learn German. Sir, upload French language. I need to learn French. This kind of things are there. Try to raise technical questions. Okay. Ayush, I don't know the last date because we are making the platform matured enough. We may close, see, once we achieve our target, probably, and within some time when more than 200, 300 courses gets uploaded, because right now it is maturing. We are updating more and more content, right? So it is important. Okay. So please go ahead and take it. Okay. And yes, this was it from my side. Why you removed your stats from beginner free course from dashboard? Because I have uploaded the course. No, full re-recorded. Entire course is actually present. Go and search for stats. You'll be able to see, Ritesh. Okay. So thank you guys. This was it. Go ahead, take up one neuron course, support us, tell all your friends. We are doing some great work and probably will keep on doing it. Okay. Thank you, everyone. See you tomorrow. In tomorrow's session, we are going to see a lot of things. Okay. Thank you, guys. Have a great day. Bye bye. MongoDB also is getting included. Okay. MongoDB is also getting included. Don't worry.